All right. You're welcome to Sir Majesty Easy World. You are live with Sir Majesty. Now, live stream today we'll be discussing LUSSAC'S law of combining volume and the calculation cheats, of course. And then we will also answer your questions. Any question that comes from the viewers online will be attended to because this should be the last live stream of the 3 consecutive days live stream by the Easy World. Please remember to subscribe and also share. Let me share this with my followers on WhatsApp so that they can join. Confused with the so-called LUSSAC'S law. If you say LUSSAC'S law without saying combining volume, we are talking about what happens to the pressure of a gas at constant volume and constant mass. It is still LUSSAC'S law that states that when the mass and volume of a gas is kept constant, that the pressure is directly proportional to the temperature, meaning increase in temperature will result to the increase in the pressure of a gas if the volume and the masses of a gas is kept constant. So, but here we are looking at the LUSSAC'S law of combining volume, the law concerning how it is dealing with the combination of volume of gases, not just LUSSAC'S law. So some might mistakenly call LUSSAC'S law pressure law. You know that Boyle's law talked about what happens to volume and pressure at constant temperature, while Charles' law talks about what happens to volume and temperature at constant pressure. But it is LUSSAC'S law now that discuss what happens to temperature and pressure when the volume and the mass remains constant. So, but today we are looking at the LUSSAC'S law of combining volume. First, who is LUSSAC'S? LUSSAC'S by full name should be Joseph Louis LUSSAC'S, who is a French chemist and also a physicist. He is popularly known for confirming that water is made up of 2 parts of hydrogen and 1 part of oxygen. And that aspect is what we are discussing today. That's his aspect of the law of combining volume. He was able to discover that when 2 parts of hydrogen combines with 1 part of oxygen, that it forms 2 parts of water, and that takes down with the idea of Avogadro's hypothesis, telling us that equal volume of gases contain the same number of moles of gases. He was able now to make this law come into manifestation, the law of combining volume. And I will state it first. LUSSAC'S law of combining volume states that when gases react together or combine together, that's chemically, that they do so in simple whole number or simple ratios, which are they do so in whole numbers which are in simple ratio to one another and to the product. If the product is in gaseous state, the condition for you to involve the product is only if the product is gas, because the law is for gases. So if solid is there, it doesn't count. If liquid is there, it doesn't count, provided that the temperature and pressure remains constant, of course. So the LUSSAC'S law is trying to tell us that when gases react, they do so in simple whole numbers. They do so in whole numbers, they do so in volume, which are also in simple whole number with one another, and to the product if gaseous. So in that sense, what it means is that as they do in mole, so will they do in volume, and as they do in volume, so will they do in mole. What I mean is that if you discover that in the balanced chemical equation that 3 moles will require 2 moles, or 3 moles will require 1 mole of a given gas, like nitrogen and hydrogen, while combining them to get ammonia, you discover that you'll be dealing with 1 mole of nitrogen to 3 moles of hydrogen. So if they use that ratio 1:3, it means that when you bring a volume that any one part by volume of nitrogen requires 3 parts by volume of hydrogen. So that's why the law states that when gases combine together, they do so in volumes, which are in simple whole numbers to one another and to the product, provided that the product is gaseous, if the temperature and pressure of the gases reacting and the product remains constant. So the condition for this to be true is that the temperature and pressure of both the reactants and the product are kept constant. So varying them will shift this law. Then having the idea, you cannot discuss Gay-Lussac's law of combining volume without discussing Avogadro's hypothesis. That is, Avogadro's hypothesis, of which I stated earlier, states that equal volume of gases at constant temperature and pressure have the same number of gas molecules. And this is also rhyming with what Gay-Lussac's is telling us today. So maybe for clarity's sake, I'll still put down the definition. So it's time for me to write. Remember, I'll finish the Gay-Lussac's law, just give 2-3 examples, then I'll handle your questions for those of you that are already live watching. I really appreciate you guys, and remember to share this link also. So we are handling chemistry, and in the aspect of chemistry we are taking a look at Gay-Lussac's law of combining volume. And it states that when gases react together or combine together, that they do so in volume, which bears simple number in volume, which bear simple or bear whole numbers, or in volumes which are, let me use the word, which are in simple ratio to one another and to the product only in one condition: if the product is gaseous. If the product is gaseous, that's the condition, provided the temperature and pressure remains constant, or you say at constant temperature and pressure. Okay, then by so doing, it's just for you that is watching. If you can copy, you copy. I believe it's very clear. Yeah, of course, it's very clear in the camera. When gases react together, they do so in volumes which are in simple ratio to one another and to the product. If the product is in gaseous state, or is a gas, that's the only condition, at constant temperature and pressure. So now, what this means is that as gases do in volume, so would they do in their mole ratio. As they do in their mole ratio, so would they do in their volumes. I'm going to start with an equation because we don't need to waste time here. We go straight and start this. Then the calculation is what we want to focus on now. We have finished the definition. Let us focus on the calculations, which is where most people find difficult. The calculation in chemistry, as usual, always look like a word problem. It always appear like a word problem. That's why some might not find calculations in chemistry very funny, because you might be looking up to see a formula. Unfortunately, you need reasoning. Like, that's what problem for you. Now let's take a look at the combination of nitrogen and hydrogen gas to form ammonia. They are all gases. In this case, balance the equation. Nitrogen is 2 here. If you put 2 here, you put 3 here. So the mole ratio here stands as 1:3. That's the coefficients, for those that don't know, is to 2. According to Gay-Lussac's, 1 mole of nitrogen will require 3 moles of hydrogen, which will also give us 2 moles of ammonia. It means that if I bring 10 of this, if this is 10 cm cube, just simple reasoning, if when this one was 1, this was 3, that means 1 times 3 is 3. So if this is 10, I will automatically say 10 times 3 to get what is here. And 10 times 3 should be what? 30. So if here is 1 and here is 3, if you bring 10 cm cube of nitrogen gas, you are also required to bring 30 cm cube of hydrogen gas. In the reverse of it, you find out that if you have, in this case, if this place becomes 15 cm cube, what will here be? 3:1. 3:1. Meaning this place, it was, for you to get here, you divide. For you to get here, you multiply. Like I say 1:3, I say 10 times 3, giving me 30. But when we move from here to here, you divide now by 3. So it means that 1:3 on the reverse is 3:1, which means 15 divided by 3 will give me 5. So if I'm provided with 15 cm cube of hydrogen gas, it means that it will react completely with what? 5 cm cube of nitrogen to give me how many volumes of ammonia? It is 1:3:2, and that is where you now solve for one part. One part here is 10 and one part here is 5. In this case, it means that 5 times 3 gave me 15. 5 times 2 give me nothing but 10. So you see the volume. If you react 5 cm cube of, I guess it's clear. Oh, sorry. Now, if you react 5 cm cube of nitrogen, it will give with 15 cm cube of hydrogen gas, it will give you 10 cm cube at the same temperature and pressure, provided you don't vary. Then if you react 10 cm cube of nitrogen with 30 cm cube of hydrogen, it will automatically give you 20 cm cube, because it is still 1:3:2. So this is still in that same ratio. If you are clever enough, what I did to this number was just to add 0, 0, 0, 0 to them, which means I was using the multiplication factor of 10 for each of them. That is it in the ratio combination. So as they do in mole, so will they do in volume. If you are finding this difficult to understand what I said, even if you can, like, let's assume here becomes 3.5 cm cube. What will this be? Simple. You just say 1 give 3. What will 3.5 give? You call it x, then you cross multiply. Unfortunately, I don't even have my calculator. Okay, let me look around. So in that case, you know, it's 3.5 times 2 is automatically 7. So it's going to be 10.5 actually, even without calculator. But let me still prove it. So when you call this place x, what happens? You cross multiply, and then get what? You get that 1x, that's x alone, is equal to 3.5 times 3, which is probably going to give us 10.5 if I'm right. That's 3.5 times 3. 10.5. Then if you want to know, it means that 3.5 of nitrogen, according to 1:3, will require 10.5 cm cube of hydrogen. Then if you want to know the volume of ammonia that will be produced, you also use the same pattern. 1 gave us 2. You say 1 gave 2. What will 3.5 give? Automatically 3.5 will give us x, which is 7. If you cross multiply, 3.5 times 2 is automatically 7. So 3.5 cm cube will react with 10.5 cm cube to give me nothing but what? 7 cm cube of ammonia. Why am I adding this ammonia? Because it's in gaseous state. If it is in liquid or solid, I will not regard this mole here. It doesn't count. According to Gay-Lussac's law, only gases are the thing being related here. So if, for example, now let's use this and take the first example in the calculation. The first calculation is example 1 here. If if 18 cm cube of nitrogen was mixed with 21 cm cube of hydrogen gas at, you can mention any temperature, but let's use the temperature that makes the reaction visible at 450 and maybe they say 200 atm. I think these are the physical conditions for Haber process actually. 450 and 200 atm. Calculate A, number 1A, the volume of excess gas, excess gas. If you have made any comments, please, I'm not looking on the screen. I'll still come back and focus squarely on your questions, please. Let me just finish and focus on the solving for now. Okay, so calculate the volume of excess gas. Then the B part of number 1 says the volume of residual gas. This volume of excess gas can also be regarded as unreacted gas. Volume of excess gas means volume of unreacted gas. Now, in this situation, before I carry on with the solving, I want us to know two things. There are two volumes we calculate for here. One, excess gas, volume of excess gas, which can also be seen as volume of unreacted gas. Then another volume calculated is volume of residual gas. So excess gas means the gas left unreacted. That is what we mean by excess gas. The volume that is left unreacted is what we call excess gas. So, but the volume of residue, you know that residue means remaining, the volume that remains after reaction, meaning actually the residue gas should include the product. But the excess gas is the one that was supplied more than required. But the residue gas is the resulting volume of the product formed. That's if the product is in gaseous form, you need to calculate it. That's what you mean by remaining. That's the volume of the gas left after the reaction. And it includes whether the residual gas here includes both unreacted gas and the product. If the product is gaseous, very simple. So if you want to know the volume of residual gas, what we're going to do is to add the volume of unreacted gas or volume of excess gas plus the volume of the product if the product is in gaseous state. But when the product is either solid, liquid, your excess gas is automatically nothing but the residual gas. But when the product is not gas and there is no excess gas, it means that residual gas is zero. I repeat, if the product formed is a gas in gaseous state, the volume of the so-called residual gas is equal to the volume of unreacted gas or excess gas plus the volume of the product formed. That gives you the total gas that remains after the reaction, and that's what we call residual gas. Then, what is the volume of excess gas? That is where the job is. I think I've explained how to calculate volume of residual gas and how to calculate the volume of excess gas, which can also be seen as volume of unreacted gas, of course. So in that aspect, what I want you to understand now is you are going to obey the ratio before you will know which gas is in excess. Taking this question as an instance, for those that are just joining, you say, if 18 cm cube of nitrogen gas was mixed with 21 cm cube of hydrogen gas at 450 and 2 atm, calculate A, the volume of excess gas or unreacted gas, then B, the volume of residual gas. It might equally tell you, name which of the gases was in excess. But if you are able to calculate the excess, you will know the gas that is in excess. Now, I'm going to copy out the volume. This particular temperature and pressure given here will not contribute in our calculation. Most times they will just tell you at STP or at RTP. Remember, STP means standard temperature and pressure, while RTP means room temperature and pressure. STP is 22.4. That's the volume of the gas molar volume. Sorry, the gas molar volume. That's the molar volume of a gas at STP is 22.4. But molar volume of gas at RTP is 24 liters. That's 24 dm³. Okay, thanks for that being there. Okay, so it means that this temperature is just to specify things. It's a condition that is provided, not that it will participate. Now, what I want to do is that because I don't have enough space on this little board, you can also sponsor us. Of course, the gadgets I've been using for the live stream. If you check my past live stream from last year, I've been using a nice gadget, iPad Pro. It has a notebook where I write everything. I lift it there, and it makes live stream very astonishing and interesting. So you can also support us to get one, because the one we have was looted, of course, by the hoodlums, and they can't stop us at all. But with your help, we will get back on our feet. Okay, now I will write out these values for the nitrogen. Volume of nitrogen I gave was 18. These are the necessary number. Then volume of hydrogen was 21. So I am now good to clean this so that we can have space for solving. The calculations. So Gay-Lussac's law of combining volume. I have to even clean here and write only Gay-Lussac's law. So in this case, solution to that question, example 1. The way to handle this question, if it comes in contact with you in exam, what you're going to do is this thing I'm doing now. Solution, you just write the equation first. You start from here, the equation, balanced equation for that matter. The equation requires us reacting nitrogen gas with hydrogen gas to give us ammonia gas. And in balancing, the states of matter are necessary. Some exam body, if it is O level, they will give you the equation. And if it is objective questions, if not JAM, you will see the equation of the reaction. But if it is a theory question, you are going to be the one to write the equation and balance. Okay, there is how many nitrogen here? We have 2 here, we have 1, so we are going to put 2 here, and put 3 here, and they are all gases. Now, the next thing is the mole ratios. You write down their mole ratios. What are the mole ratios? Mole ratios. 1:3 is to 2. Next thing is given volume. You write the given volume. That's the volume that was given in the question. Write it exactly. So what you do is, under nitrogen, what was the volume of nitrogen given? You write 18 cm³. Under hydrogen, what volume was given? 21 cm³. This one was not given, so it is empty. You can't write anything there. Then the next thing is normal reacting. You now write normal reacting volume. This is where your work lies. Normal reacting volume is where you now use this ratio, 1:3. You either move from here to here or from here to here. I'll teach you, no direction is the best, but in a given question, one direction is usually preferable than the other. So in that aspect, what we're going to do is let's move the other way, which means if, like I told you, this wasn't in a simple way whereby you can even multiply. If you want to move like this, it becomes 18 times 3. But if you want to move like this, it becomes 21 divided by 3. That's if you want to get what will be here. I said if you want to go from 1 to 3, you say this under 1 times what is here. But if you want to go from 3 to 1, you say this 1 divided by this. I guess I'm making sense here, making it a simple way for you to solve questions. Okay, But let me take it, you don't know or you don't understand what I explained. What you just do is do your normal math. 1 gave you 3, 18 will give us x. By so doing, 18 will automatically give us, this is x, 1 times x is x. X is equal to 18 times 3, like I told you. 18 times 3 is 54. So it means that when I move in this direction, it is going to be, what will be here is 18. I'll write same 18 because I held this 18 constant. That's why I started from 1:3. So 18 will normally, that's normal reacting volume. If this is 18, what here is supposed to be is 54. And what will this place be? This place is not yet our business, actually. We want to know if this direction is correct. If you move, remember I moved from 1 to 3 and I saw this, I held this one constant. What you do is just put minus here, put minus here. 18 minus 18 will give you 0 cm cube. Then 21 minus 54, 21 minus 54 will give me minus 33. If it gives you negative, it means you are going to move the other way around. As you have seen, this one shows that it's negative. Negative means that you need to go and supply excess of 33, but that was not, you were just provided with 18 and 21, so you can't go and borrow this. This is deficient, but they are asking you the one that was excess. So it depends on the question. You know, if I'm taller than you, invariably you are shorter than me. But this time around, they are asking us in one direction. So let us focus on their own pattern. Please don't type question yet. Let me, when I come facing the camera or the screen, you can now come with your questions. Okay? Now, what it means is that I'll have to change. Instead of starting from 18, I'll start from 21. When I started from 18, I say 1:3, but now I'm starting from 21. What will I write is now? I will now write 3 first. 3 gave me 1. What will 21 give? 21 will give me x. Cross multiply, it becomes 3x is equal to 21 times 1. Okay, so 3x is equal to 21 times 1. At the end, 3x is equal to 21 such that x, because the camera is there, yeah, such that x is equal to 21 divided by 3. 21 divided by 3 is 7, so it's going to be 7. So I'll now clean and change this place to 7. This will now be 7 cm, and here remains 21 constant. And following the order, you can still do the same thing. If here is standing as 1 and is automatically 7, it means that here will become 14. That is 7:21 to 14. That is it. This second one is correct. If you don't understand how I get this 14, you can say 1 gave 2. What will 7 give? Simple. If you don't understand how I got that 14, but I use 1:3:2. Now, in this case, you put minus again in each case. When you put minus, you say 18 minus 7 here is 11, probably. 18 minus 7 is 11. You say it's a positive number now. So that means this movement is correct. Depends on how the equation is. I did not say you must go from this to this because I might twist, I might start the equation with hydrogen. That's why you should not memorize. I might start with hydrogen, but here I started with nitrogen. So whichever, if it gives you negative sign, move the other way. If you move from 1:2 and put minus and get negative sign, you now move from 2:1. That is just the secret. Okay. Now you put minus also. 21 minus 21, 0 cm cube. Very correct. We have gotten our A, which says excess gas. It means that the 18 that was provided was too much. Not the whole 18 will react to 21. Out of the 18 provided, only 7 will react, such that the excess gas will now be what? Volume of excess gas is equal to 11 cm cube. Imagine that. So which of the two gases was in excess? Which of them? It was nitrogen. Imagine where 18 is regarded as being in excess in the presence of 21. Yes, that is LUSSAC'S law of combining volume for you. It is not usually that way you think, that will give you the correct answer. So volume of excess gas is equal to 11 cm cube. Simple. Then B is volume of residue gas. From what I told you, that volume of residue gas is, by formula, volume of residue gas is equal to volume of excess gas plus volume of product. This is equal to volume of excess gas or unreacted gas plus volume of the product. Am I permitted to add the product here? Yes, because it was in gaseous state. Let's assume it was in the liquid or solid. I will not add these two, 1:3:2. I will only use whatever I have here. Automatically 11 cm cube becomes both my unreacted and my residual gas if the product is not in gaseous state. So you should be mindful while solving an exam. The state of the product is necessary. Like if I will use water in the subsequent example. In water, they may tell you and water vapor is formed. If they say water vapor, that means the product is gas, because water vapor is in gaseous state. But when they say the water formed is cooled, if you ever hear cooled, it means automatically that you are no longer going to consider the volume of the product, of course, because you are talking about combining volume for gases, not combining volume for liquids. Okay. Now, what is now the volume of excess gas? We got 11, and that means 11 is the volume of excess. What is the volume of product? 14. So 11 plus 14 will give you automatically 25. So 25 excess volume of residual gas. See, the volume of residual is 11 plus 14. This is the 14 gotten by 7:21:14. So that's the first example, clearly explained. Now we take another example. Before further example, if you have question, if you what I'm saying very clear, you ask question there. Before I move to example 2. If I move to example 2, you might ask a little question. Although remember, this will be saved even after the live stream, so you can do yourself a favor by rewatching. Anywhere you are lost, you still go back after the live stream, not actually now. So, and then I wish to remind you that you're on with Samantha Science Channel. You can book for your private classes, of course. They are affordable for your schools, for your children. Of course, you do this contacting me with the number plus 234-7065-166-217. If you are calling within Nigeria, you just say 07065-166-217, or you chat. You can also indicate in the comment box of any of my videos. Please subscribe if you have not subscribed, then endeavor to share. Also remember that Her Majesty makes available laboratory equipment, even hospital equipment, laboratory equipment as it concerns chemistry, physics, biology, and also I help in quality control and productions. Please, I cannot do without you. Thanks for being there, especially for helping me get to 10,000 subscribers. We have still a long way to go, because I believe that only the best is good enough. Bonum eligere. Aiming at the highest good known is my target. That was the motto of my alma mater. Okay, back to the business. We are going to take example 2. I believe, how many surviving online watching now? Okay, no question, and that means I have to forge ahead. Then example 2, say say 20 cm cube of oxygen was sparked with 30 cm cube of hydrogen, was sparked with 30 cm cube of hydrogen gas. STP, or they spark, they might tell you, and if the whole volume is measured at STP, it's possible in that way. Then what next is this: you now just like we did, you'll be told to calculate a volume of unreacted gas, B volume of residual gas. Although this question did not specify, that means I have to give you an equation. Normally they're supposed to tell you, and they will tell you the state of the water formed, because these two things will form water. So the volume of the residual gas, assuming the whole thing happened in gaseous state, you might be told, assuming the product remains in gaseous state, assuming the product remains in gaseous state. So in this case, our job is just to still do the same thing. Oxygen is 20, hydrogen given was 30. So what do? We just I'm going to clean off this, but let me read for those that 20 cm of oxygen was packed with 30 cm of hydrogen at STP. If all volume of the gas was measured at STP, that's the meaning, and the whole thing happened in gaseous state, they say calculate the volume of unreacted gas. B says volume of residual gas. 20 cm of oxygen was packed with 30 cm of hydrogen. According to the equation below, these are the ways the question might be constructed. But what matters here is for you to just see the steps involved in the calculations. Okay, then we will write solution. Judiciously and religiously follow the steps. So the solution to example 2, we just repeat what we did in example 1. We first of all say you need the equation, and here we'll write the equation: H2 reacting with O2 to give you H2O. Balance the equation. There should be 2 here because of these 2, and then 2 here. Gas, gas, and gas. If I write here L, the whole story changes. It means that I will no longer be regarding these 2 moles again. It is no more significant for me. This particular, if it is L here, that's liquid, meaning it has been condensed. But if it remains vapor or gas, it matters. Now, what is the next thing? You write the moles, the mole ratios. 2, that's the coefficient. 2:1, which is here, is to 2. Please, it means if you can't balance the equation very well, it automatically shows that you fail this question. That's the problem with this Gay-Lussac's law. But if you balance well, that gives you the first edge to success. The next thing you're going to do is you now write given volume. As I'm doing it here, you'll be trying yourself there. Given volume under hydrogen, what volume was given? 30. And under oxygen, what volume was given? 20. They did not give us water that was formed. From this, you can predict the volume of water formed. Okay? Then, what do you do next? You now write normal reacting volume. Normal reacting volume. You follow the ratio 2:1. So, if you want to get this now, if you want to get anywhere there is more number than 1, divided. But if you are moving from 1 to any number more than 1, you should say multiply. 2 is more than 1, and I'm moving from 2 to 1. It means if 30 should react with, if 2 should react with 1, 30 will react with automatically 30 divided by 2. I take it again. 2:1, and I'm moving from higher number to lower number. I'll divide the number below by these 2, meaning it's going to be 30 divided by 2. But if I want to move from 20 is to 30, it means I'm moving from 1 to 2. I'm moving from lower ratio to higher ratio. It means I will multiply this by the number here automatically. So if I want to say 20, if I want to hold 20 constant, it's going to be 20 will give me 40. That's 20 times 2. But if I want to hold this place constant, and write 30, it's going to be 30 will give me 30 divided by 2, which is 15. If this is still confusing, you simply, if 30, normal 2:1 means 30:15 is to 30 also, because 2:1 is to 2, 30:15 is to 30. If this reasoning you are finding is difficult to know, just simply write 2 give 1, 2:1. You now hold here constant, 30 will be x. Automatically 30 will be, you cross multiply, 2x is equal to 30 times 1. I guess it's still clear in the camera. Okay. 30 times 1 will give you 30, so that x is equal to 30 divided by 2. Simple. Which is that thing I said. I repeat, if your ratio is moving, if you are moving from a lower ratio to a higher ratio, you multiply the number in the lower ratio by the number in the higher ratio. If you want to hold 20 constant, 20 have 1, which is lower than 2, you just say 20 times 2, here will be 40. Then if you want to move from higher number to a lower number, that's higher ratio to a lower ratio, you just say divide by the number on top. Okay, so at the end, we now put what? Minus in each case. Remember I said if it gives you negative answer, you move the other way around. But if it don't give you negative answer, it means you are correct. 30 minus 30 is 0. So all the hydrogen gas reacted. Then 20 minus 15 is 5, which is a positive number. So that means this ratio 2:1 is correct. Holding 30 constant is correct. If you do 20:40, you get negative. 20:40. If you put minus, it becomes 30 minus 40. You'll be owing. But the question say calculate the one that was in excess, and you are busy calculating the one in short supply. Okay, now in that case, what do we have? Our excess gas is automatically 5 cm3. And which of the gas was in excess? Oxygen was in excess. It still reflects. So don't use your common eye to answer, because to a common man, 20 cm3 of hydrogen reacting with 20 cm3 of oxygen, automatically somebody will tell you that 30 is in excess of 20. Now, no, this is not the reasoning here. You're going to visit the mole ratios, do your calculations, and know which of them is in excess. So it is obvious that the volume of excess gas is now what? 5 cm3. The volume of unreacted is 5 cm3. Then what is the volume of residual gas, or the total gas? They might tell you what's the volume of the total gas remaining after the whole reaction. The total gas still mean residual, please. If they say the volume of the total gas, that's the whole gas remaining. It, because this 5 that did not react was oxygen, it will still remain with this volume. So what's the volume of product from 30:15 is to 30, which is 30, and that makes it 5 plus 30. The volume of residual gas here is 35 cm3 automatically. So, but let's assume in the question they tell you that 20 cm3 of oxygen was packed with, or 30 cm3 of hydrogen was packed with 20 cm3 of oxygen at STP, and the gases formed were cooled. If you hear the word cooled, it means exactly that it is now in liquid. If the gases were cooled, this will now become liquid. And the question says, what is the volume of residual gas? My dear, the volume of residual gas will automatically be 5 plus 0, because there is no gas again in the product side. This 2 is now liquid, and the LUSSAC'S is for gases, not for liquid. So in this case, if the products are in gaseous state, you add them. But if it is not in gaseous state, you don't add them. Then what if we have a situation of more than 2 products? Because it's possible, like in the case of reacting steam ion with steam, you can still have something that way. Let's assume you have something that way. You have ion 3, diion 2, diion 3, ion 2, diion 3, ion 2 plus hydrogen. This is gas and this is solid. This one is gas and this one is solid. Though the LUSSAC'S law is not applied here, but I want to use it as an instance. Why? Because it's not gas and gas. This is solid. Like if you come here, if you must add any more, balance the equation, what must be here is 3. Automatically what will be here, it should be 4 because of the oxygen that is 4 here, then 4. If you want to relate more, it is this 4 that you add, assuming there are more than 2 products. you will not regard this one here because this is solid. It is only this 4, which is in gaseous form, that will count for you, just in case. And it's only this 4 also that will count. This is also useful in the case of a LUSSAC'S principle to study the effect of change in pressure, like this. Although watch down my video here on LUSSAC'S principle, it is completely simplified and made easy. You are on with Her Majesty Easy World. I'm available for you at easyworldscience.com, or you can get me on WhatsApp with +234 7065166217. Book for your private classes, also for your schools, for your child, and for yourself. Also, join the League of Testifiers to testify. Okay, I guess we have done justice to Gay-Lussac's law of combining volume. Today marks the end of the live stream, 3-day consecutive live stream, and what I want to do next is to see your questions for a few of you that are online now. If you have any other challenging question, you can bring it now, but in the absence of any challenging question, it means we are ending this live stream, and it is an honor, it's a big privilege having someone like you that stumbled onto this video for the first time. Maybe you weren't there when I'm on saying this. Endeavor to visit my channel community post. That's my post on this channel, my community, so that when I ask for topics to be discussed, you can contribute there. Follow up, because that is the only place I can communicate with my followers in terms of writing, updating things. That is where I will hear from you automatically. If you find anything difficult, I might ask. It will be coming periodically where topics that you are finding difficult will be treated. Today, I'm supposed to handle waves. No, I'm not an expert. I'm not an expert in physics, so the waves will now come up as an upload, an introduction to that. It's going to be a video. The person that I'm supposed to link, that person is actually in the United States of America. One of my students, he's currently, I established him here on this channel. He did wonders, and he's under scholarship. Yeah, that reminds me, we thank God, and I want you to also participate. So I've checked linking him to join here. I don't have that activities. That time I have the gadget. He will directly connect to you guys over there. But what he did now was to record the video and send across. So after which I will upload. He's the guy that handled the physics this past WAEC. He's a great guy. The little intro will come up as subsequent upload. So please, right now, I want to hear from you. For those of you that I couldn't choose your topic on the question I asked about a month or 2 months ago on my community about the topics to be handled, there are many topics that was stated there. Please, your questions. I'm watching my screen now. Use the live chat and ask your questions in chemistry. Don't ask to test me. Ask to learn. I don't know everything. Of course, you know, it's not possible. I don't even know divided by 3 million of the contents in chemistry. So please just ask. And I believe God, I will answer your questions. If you do, come with your questions. Come with your questions. It might be within the Gay-Lussac's law of combining volume or outside the Gay-Lussac's law. It should be physics. It shouldn't be physics, please, but it should be chemistry. That's what I mean. Okay. The grace is still on. If I wait a few seconds more, I'll end the class. As I wait for your questions, you can also come alongside with your suggestions on how we will do this channel to make it better. For you guys that are following me, I need to hear from you, and you can only do that through my community post and the comment box of my video. But you know, you should be polite with your words. There are some comments, if it shows a lot of uncivilized speech, I might not respond to those comments, but make it civil and make your point there. 2 good heads are better than 1. And don't forget that I supply reagents, I produce some chemicals, I sell, produce, check the quality by myself, so you can buy from a reliable source, and that is Her Majesty. I will help you, guide you, make use of anything you're buying from me. I'm not just a marketer, but a scientist, so I know the content of what I'm producing. I'm not seeing any live chats coming on. That means those online are so much satisfied. Thank you so much, you guys, for being there. Remain majestic. Bye for now. Keep in touch.